Good evening, everybody. My name is Nico. I work for Golaem, and I'm gonna be your host for that new live session, which today is gonna be about physics best practice. So we're gonna make some characters exploding and also see how we can configure the physics for any kind of characters here. In the meantime, also Alex from Golem is going to be moderating the chat box. So if at any time you're having a question, feel free to put it into the chat box. And after those 30 minutes of showing you how does the physics system work, we'll probably also handle a question and answer sessions. Just to let more people joining, if there are some late people around, let me remind you that today and tomorrow we're going to speak about physics. And starting next week, we're going to go down to one session per week. So I'm not sure if it's going to be on Thursday or on Friday. Check the website to get more information about that. But next week, we're going to speak about clothes setup. If you want to make a cape or flag for a character, we're going to show you how you can configure those. And the week after, we're going to see how to build a complete locomotion set from scratch. Well, from animations. So we're going to take a couple of motion clips. I'll show you what makes a good locomotion clip. And we're going to assemble those to make a complete locomotion set for our characters and to have a nice and great animations when we need to reach a target or avoid other characters. Sorry about that. So let's get started with today's session. In today's session, we're going to configure that guy here so its physics will look proper. And within my scene, let's take a look what I have. I have one pop tool which is creating 4 characters here, which is 4 times the same character file. I'm having my 4 entity types. One is named kinematic, one is named dynamic, one is named local servo, and the last one is going to be word servo. So those 4 types here, if we just quickly take a look of what they're doing, they're just playing the same animation here. And the whole goal of those 4 types is to show you what are the different modes, the physics modes you can use, and when do you need to use them. So first, you can see right now the viewport is not showing the geometry of the characters. It's actually showing what we call the physics shape. So let me actually show you how you reach that. So whenever you configured the skeleton of your character, you're able to load that character within an entity type. So you don't have to have the geometry of that character. If we actually take a look of that character here, it's just the geo. It's just the skeleton part. The geo is not defined, so that one here is just empty. So those are just remaining node that I need to delete. So that's my character here, and it doesn't have any mesh, but still I can actually see it into the viewport. I can see it if I pick the mode being cylinder. I can see his avoidance collider, which is going to be used to avoid from the other characters. I can use the animation bones, where we just display a box for any bones we're having on the characters. And finally, I can also display what we call the physics shape. So how's the characters going to be approximated in terms of physics colliders. So those shapes here, obviously they can be configured, and that's going to be the point of the beginning of that session here. I'm going to configure those to make them more appropriate for my actual character. So let's maybe first take a look at this. So this is what you may see in front of the character. That's what we call the character maker locator. And that shows you how the characters is made in terms of skeleton chains, but also in terms of shapes. So let's jump into the character maker locator. Let's go into the skeleton. So the first thing you want to make sure is correct onto your character. So let me probably remove those fixed shape just for a while. So I'm gonna just select my character maker locator here and not display the ragdoll volumes. So we had amongst the first sessions that we made, we had a full sessions about how you can convert your character, so please report to those if you want to know more about that. But before jumping into making the physics of your characters, you really want to make sure that those white planes, which are defining the pole vectors for your limbs, you want to make sure that they are into the proper direction. So what it's saying here, it's saying that my arm the I key is gonna fold into that direction here. So it's folding behind my characters, and we can actually like check how it's folding by using the check button here and changing the length. So we can see that when it's using Golaem and when it's making an I key, the arms is actually folding into that direction. And if you're not happy with that, so that's my left arm here, you can change that I key direction at any time. Oops, that's my right arm there. So here it is. So you can change it at any time to make sure it's following what you want your characters to actually do. So let me go back to what was there before. I'm not sure what was there before. So that was probably Z or minus Z. Nope, not that one. Sorry. Let's go back to minus Z here. So star, yeah, here it is. So really want to make sure that the pole vectors are configured properly, because those are going to be used to define the joint limits. We're going to explain what are the joint limits a bit later. So here my characters is proper in terms of pole vectors, so I'm good with that. Now I can jump into the physics properties. So let me show you the default physics properties that we've been defining. So those are the ones. So there we kind of have a process which is analyzing the size of the bones, the way they're connected, and it just creates default shapes with default sizes here. But it's really up to you to figure what's the closest to your actual character geometry. So you can see here the head is not really proper, it's just a small capsules here for the head, which is not really approximating the whole geometry properly. You can see the ends also, they're not really containing the whole shape of all the fingers, so we're going to change that. And finally, I guess we're going to change maybe the feet and also the torso. So how do we do that? We just go into the physics properties and edit those. So when you edit those, what you ended up with is that spreadsheet which for each bone that we define should have a sense in terms of physics. You got its properties. So the properties is going to be, the density, it's going to be the size, it's going to be the shape we're going to use. And by default, we hide unphysicalized bones. So all the bones that we figured may not be important, that like maybe the fingers, they just ignore. So they just define as physicalized false. If you want to change your mind on that, you can just switch that false to a true. And when you're going to press that button here, that list of bones will be updated with the right ones. So let's maybe focus on what we need. So if you select a mesh, so as soon as you open the edit properties, those shapes turn into real Maya meshes that you can select yourself, and you can actually see them here and probably scale them, change their shape, replace them properly to align them with your geometry. So all those meshes, they're right below the character maker locator, which you can open and you can see the different ones. So I'm having a spine bone, a spine free bone. I'm having a neck. I'm not sure if I really need the neck. Let's remove that one and let's put the head instead. And probably I want to have also the in-between spine bones. So usually my first step is removing the bones that I'm not gonna need. So the neck, I'm just gonna remove that one. So I'm gonna put a false here. As soon as I put false, you can see it disappears from the list because I have the hide unphysicalized bones. The rest is pretty okay. So here between the spine and so I've got the hips and the spine. So yeah, I probably want to have also spine 1 and 2. And want to control those, so you can see they're here. So I can select both of those physicalized options, press space and set true, then enter, and now you can see those are turned on. And if I go with apply, there's a chance that you can see now those appears within the viewport, and it changed the previous one as well. So yeah, first step is usually figuring which bones you want to have, which will approximate better your character. So I'm probably gonna be good with that. Next step is to figuring if the shapes are gonna be correct for all of those. So it's usually like a good idea to approximate hands as boxes rather than capsules, because when your characters fall on the ground, they're usually gonna be onto the upper part of the hand or the bottom part of the hand, so you probably want to use like a box instead, and that goes that's the same for the feet here. So to do that, I'm gonna go into the shape, so it's all set up as a capsules, and my left hand here, I'm gonna turn the shape into a box. So you got other options which are sphere, cylinder, box, and capsule. So those are just like primitives which can be used by the physics engine to make collision computation easier. If we were actually using the real geometry of the character, which is here 26,000 polygons, it will take way too long to evaluate if each vertex are in collision with other vertices. So what we do is we just approximate characters with regular shapes here. So I'm gonna say that my hand, I prefer them to be a box. Let's do something similar for the right hand as well. I also want my feet, so my right foot here, to turn into a box, and probably also my left foot here. And final step of modification here is probably I want to set the head as maybe a sphere rather than a cylinder. When I'm happy with that, as always, I just press apply. And now you can see that those shapes here are being turned into a box. Those shapes there are being turned into the box. They're not properly scaled nor orient. So we're going to change that. And you can see that my head is pretty small here, but that's been turned into a sphere. Next step will be to maybe change the size of those. So I can go into the auto size and specify some attribute manually, or I can go within the viewport and rescale and replace those the way I want to. So before, and that's really important notice here, is before actually moving the shapes, make sure to close that panel, because if you don't close that panel and you press OK, what's going to be approved, what's going to be written into the character will be those attributes here. So if you do some modifications and then you press OK, you're just going to erase those modifications. So I'm going to just press OK first and change what needs to be changed into my character. So it should be maybe more accurate to go into that view here so I can align my characters together. So I'm going to grab, probably I'm going to start aligning my sphere, which stands for the head. So I'm going to go into the scale tool here, and I just want to more or less approximate the characters. So yeah, this is how it's going to look. So that's going to be my eps are going to be that one here. So it's probably, well, you know what, I'm gonna turn that to make a better approximation. Well, if I wanted to do this properly, I'll probably like check if my values are correct, but you get a sense, right, of what I'm doing here. So I want to apply like a uniform scale here, then I want to take the spine, probably goes with something similar here, and scale that a bit as well. And there's apparently like another bone here. Okay, so that's spine 0 here, spine 1. There's maybe like way too more of those. Maybe I don't need that spine node anymore. So let's go into here, that spine 1 here, put that to false, apply. So it's gonna probably disappear, apply. Okay, so now I can deal with that. And probably later I'll also speak of why I did that. It's really important that we got the right numbers of shapes here. Let me finish with this. So also orient that one properly. So I'm not really good at manipulating stuff precisely within Maya. I'm pretty sure there are some shortcuts that we can use to have align shapes. So okay, let's have a word about that. Well, not about orienting stuff properly, but what I'm gonna try to do here is make sure that my geos don't collide with each other within the T-pose. So that's something which is really important. Is here, if two shapes which are not related to two bones which are next to each other are in collisions, it's going to make your characters exploding. So let me give you an example here. this is going to be the spine 2 representation here, and that's my left or maybe my right arm. That's probably my right arm. So those two bones here, they are not connected directly to each other. There are some intermediate bones such as the clavicle and so on and so forth, which are already in between. If those two meshes are in collisions, like say like this, well, even more, but let's say like this, if they're in collisions, when you're gonna turn your characters into physics, this is gonna like understood by the physics engine like as a collisions between two dense meshes, and it will make your arms of your characters exploding. Rather than if those two meshes, if that approximation shape collides with that one, or if like the upper arm and the regular arm collide with themselves, it's okay because the two bones are actually in connection with each other. So the upper arm is in connection with the lower arm. So if there's a collision between those two meshes, it's going to be ignored. So that's something which is really important, and that's a question we get really often on support is, okay, I turn my characters on with physics, and I'm not sure why, but my characters just explode even if I didn't ask anything to do. So that's something you usually need to check if are there some collisions when your characters start being simulated. So let's put that to some proper values here. So that's probably going to be 180 degrees. Okay. And for the final shape, well, probably I would have need the neck here, but whatever. The idea is just to make some easy work, right? Okay, so something like this. I probably will have to also rescale my hand. Also maybe change the orientation of my feet. And this is what I'm going to do out, and probably align that properly as well. So yeah, my orientation is not proper here. So that's going to be a 0 there. Minus 90 degree. Well, this process can be time consuming, but the really nice part about it is that you just do it once, and when it's ready, you're good to go. And maybe, well, yeah, just to, make my point here. Let's say you're happy with that setup here. You really, you figure it's pretty nice, that setup, and you want to test it. You can save it. As soon as you save it, those shapes, they're going to be the one which will be applied to your characters. And so you can realign when it needs to be realigned, but you can get at any time, a nice evaluation of what's going on here. So yeah, my rigid bodies are not properly set up here, but well, that's funny. And if I actually want to check if my physics is made proper, what I can do is I'm gonna verify my shapes on that yellow character here. So I'm gonna jump into this. It's usually a good practice to set up a simulation scene next to your character configuration, so at any time you can figure if it's good. And I'm gonna bring a physicalized behavior, which is the behavior which is gonna be used to turn my characters into physics. So dynamic rigid body, and right away I'm gonna turn that trigger so my characters start directly by playing into physics. And here we go. So when just applying some gravity and some dynamics, this is what you get. So it's already okay. You can see that the legs, the knees, they're falling into the proper direction because we set up those pull vectors properly. So the legs are actually going to the right direction. Maybe the joint limits here onto the tights. The upper part of the leg is probably a bit too much, and maybe we can jump into this and figure this out. So, wow, you get the shape idea. I'm going to start with the shapes, but you get the shape ideas right. So let's say we're not happy with those joint limits on the characters. We don't want the characters to be able to, rotate their legs like this in the back. We need to change here the joint limits for those legs. So I'm going to go back into my character maker here. I'm going to say I want to hide my app primitives. And what I want to know is figure what's the axis here and what direction correspond to bending the leg backwards. So I'm going to increase maybe my bone radius a bit, and I can also show what's going to be the bone angular limit radius. So let's turn that in. Quite big, let's say, and the bone axis radius as well is going to be big. So now we can see what's the axis of this bone. So probably the joint limits I want to play on is going to be on the x-axis. I don't want my characters to be to have the legs bending a lot like this. So what I want to do is change my joint limit. So I can go into my physics properties spreadsheets again. Oops, I want to turn that off here. And I want to figure onto my right leg what's right now the joint axis. So as soon as I select the right leg, you can see with those half circles in different colors. So there's just one right now. But you can see what's my joint limit right now. So I'm allowing my leg to go anywhere here into that space here. So which is not exactly what I want. I want my leg to be able to fold a bit in the front, fold a bit on the right, but not as much as this here. So I'm gonna go into my joint limits here. So that's probably at the end of the spreadsheet, and you can see that the joint lower limits is gonna be 180 degrees. So that's not exactly what I want. So what I need is I'm not sure. I'm not really like a stretchy guy. Let's say, let me think about this. So that's probably minus 90 degrees, right? And in the front, it's probably a bit more than this, like 110 degrees. And if I press apply here, you can see now that your range of joints has been shifted, and now your legs, when your characters will turn into physics, they're gonna follow that rule here. And also we can probably put some, well, the legs don't really twist. Well, mine don't twist much. Probably yours do. But what we can probably do is maybe change the value of the z-axis. So right now my character's leg can't go really on the left or on the right. So maybe we can provide some upper and lower limits here. So I don't know, minus 20 degrees should be like something good, and probably 30 degrees on the exterior part of it. So let's press apply, and now we can see in blue appears the once again the space in which that bone will be able to move. And we can do something similar for the left leg, right? They're having the same axis, so that's gonna be probably the same values here. So that's my what's gonna be my other leg here. So left leg here. Oh, that was the knee, right? Ah, damn. Okay, I didn't configure the proper bones. Ah, shame. Okay, so what was the upper leg? Okay, so that was the upper leg orientation, which was not that bad. Oh, damn. Okay, well, you know what? I'm gonna put those values back. Anyway, so what was, let's go back here, upper leg, here, which one it is? So that's the one here. Okay, the name of the bones are not really sweet here. So right leg, so that's actually the knee. So that was probably like minus 180 degrees. So that was correct. Sorry about that. 180 degrees, 0. So that was 0, which makes sense because the knees are just a one axis of orientation. So okay, let's go back into the upper leg. So let's say I don't want my characters to go that far in the background. I can go with a 0 here instead. Well, I'm not twisting the legs. I'm pretty sure we can't twist the legs by 90 degrees. So let's put like a 40, 45, minus 45, 45, and probably same values here, minus 45, 45. Okay, we don't care about the color. Apply. Okay, so here I just reduce what's available for the leg. Let's do something similar really quick here. Put a 0 here for the lower limits. Put a minus 45, 45, minus 45, 45, and twist out that color. Okay, and if we save this, and we now go like this, it's a bit more obvious. You can see the legs are less within the bag. They're still within the bag because there's probably like a big constraint. So even if your setup joint limits, if there's a lot of force which are breaking your characters, you may sometimes break your joint limits as well. The physics engine tends to follow the rules, but if it can't, it does it best. If you want to tweak this, also within the physics attributes, you can go into the ragdoll advanced attribute, and you can play with the joint limit stiffness and damping if you want if you want the physics engine to respect more the constraint that you're providing. There's some advanced attributes you can play with. But yeah, that was just to give you an idea of how we can play with those. Final parameters we haven't really spoke about is when you go into the edit sections, you can also specify if you want to use a mass. So if you don't use a specific mass, what we're going to do is going to use a density. So the density represents the numbers of, I think it's kilograms per meter squared. Meters at the cube power. So that's the density of the human flesh. If you want to say this piece, whatever the size it is, it's 10 kilograms, you just say, okay, I want to use the mass instead of having a density which takes the volume into account. You turn that to true, and you just put 10 here, which will say it's 10 kilograms, whatever the scale, whatever the volume, it's going to be 10 kilograms here. Then you have restitution, so how much does it bounce, friction, how much does it friction with over surfaces. So let's say you got something which is really soapy, so really slippy. You probably want to have really low friction on either the characters or on the over surface you're gonna slide with. You got damping, and finally the joint limits. And just a quick word, we also have in colors. If you attended the previous sessions, you already know that those colors can be used to filter collisions. Let's say you want to make sure that characters get hit in a specific part of its body, you can use the colors to filter that. So okay, let's say I'm happy with that the configuration of my characters is pretty what I wanted. How do I use those now? So you may notice that when I set my characters physicalize behavior to put it into the physics engine, I had a drop down here, and we haven't really spoke about the other options here. So we can see here we're having 4 different options. So what I'm going to do is set those 4 different options on the 4 different types. So my yellow guys is going to be the dynamic rigid body. And I'm going to change probably, so here it's, I change the trigger right away, the stopping trigger right away. So like at the first frame, my characters turn into the physics character. But let's say we're going to do something more advanced. So I'm going to say at frame 10, I want my characters to jump into the physics. Then I'm going to have the kinematic character. So I'm going to drag and drop a physicalized behavior here. I'm going to set that physicalized behavior onto the kinematic option. And I'm going to set a trigger, which will be really similar here, which is going to be frame 10. So let's see how it goes. So we'll have the yellow character, which will be dynamic. So at frame 10, you can see it starts falling. And you can see that guy here. Even if we said that at frame 10 something should happen, nothing happened. So that guy is actually into a kinematic character. So it means that, so dynamic means that animation is not played anymore. And what your character is just a full ragdoll. So your characters is just getting applied with gravity and other forces you have in your scene, and following the joint limits and the resistance and the damping and all the rules that you've been specifying is just following all those rules, and it's all run by the physics engine. So even if there's an animation still playing, if we select that guy here, it's still playing that work animation we've been providing. Even if there's still an animation being played, the physics engine takes full control of the posture. That guy here is the exact opposite. So it's part of the simulation, the physics simulation. It is in it, but it's in it, but it's fully controlled by animation. So it means that it exists into the physics world, but it's controlled by animation. So when do I need to use that? What's the point of using that mode? Well, let's say you have, I don't know, maybe dead bodies into the ground, or you got that shape here within your scene, and you want your characters to hit that shape, and be able to interact with it, that's exactly the use case here. So when the characters is turned into a kinematic mode, it means that it exists within the physics world, but it just interacts on the physics world, but the physics world don't interact on it. So if I turn this into a crowd rigid body, just to say that this is going to be an actual character here. We'll speak about the rigid body tomorrow, by the way. It's going to be the whole purpose of tomorrow's session. But when the characters, let's say it's a dynamic object here, same rule, right? If it's just a kinematic object, it won't interact at all. But, okay, I'm not really sure what is not working here, but that's supposed to work. And when the characters actually hit this, let's say it's a box, you should get a proper collision. Okay, maybe my characters is not kinematic, right? Let me check what's going on here. So, is frame 10 turning into kinematic? Okay. Wait a minute. Let me figure. Okay, that's weird. Okay, so when I'm not sure what's going on here, what I usually do is I go into the display attributes. So we tend to show what's going on in terms of physics, but sometimes we don't exactly display exactly what's going on in terms of physics engine. So we can use the draw collision shape option of the physics engine that we're having, and we can check what's going on, but they're actually colliding with each other, so there should be something going on here. Okay, I'm not really sure it's not working. I'll figure that in, and I'll probably let you know into another session. But yeah, we can see the characters is like fully kinematic here, and they should actually interact with that poor sphere. Okay, let me figure that probably later, but that's the theory. There's probably something that I missed here. Maybe if I check if I'm having any errors. I don't. Okay, never mind. But this is usually the use case here. When you need the characters to interact with your environment, you set it up as kinematic, so whenever it kicks in something, it will just have the proper reaction. So next is going to be the blue guys. Here, the blue guys, I'm going to set them into the third mode. So I'm going to go back into my physics here. I'm going to go into local servo, and local servo means I'm going to put a 10 frame lag here and see what's going on now. So dynamic was, it's the physics taking the full control of the character. Kinematic is, it's the animation taking the full control, and local servo is going to be actually both at the same time. So we're going to have an animation being played, and at frame 10, you can see that the character now is going to be physicalized because it felt on the ground, it collided on the ground, but it still tries to play that walk animation. So probably it will be a good idea to set up another animation when the characters fall, because here it's just playing. So let me just remove that draw collision shape. So, but after 10 frames, you can see the character fall and still play that walk animation. So when you need to have, because the problem with Ragdoll is you can see when the characters fall that it's completely lifeless, right? It's just falling. It's not even trying to find this balance or like try to get back to its walking position. It's just falling like it is. It's taking the velocity, the previous velocity into account, but it's just following in not really natural way. So what you want to have are those, trying to get back your balance or moving your arms when you're falling. That's something you don't get from a physics engine. That's something you get from animation. So probably local servo is the right mode to use, is to trigger like an animation when your characters fall, and combine that with physics, so you get proper collision with the ground, with the other objects within the scene, but still having a nice animation being played. So here it's going to be combination of the physics and the animation, except on one part of the character, which is the root. So here the root bone is not driven by the animation, which means that the character if there's just a slight modification of their balance, they're gonna fall. So most of the time they're just gonna fall. And here they're playing animation and physics on all the part except on the root of the character. Well, the root of the character is just gonna be full dynamic mode. So what if I don't want the root to be full dynamic mode? I also want to have a combination of the physics and the animation. That's the final mode here, which I'm going to apply on my red character. So I'm going to go into something we called word servo. And word servo means that now even the root will be taken into account into that computation. So I'm going to set that regular value to 10. And if I play here, I should probably will see my characters playing my walk animation. But if I try to put an obstacles in front of them, maybe within I'm gonna put it maybe high into the scene, maybe a bit higher, something like this. So maybe on the side. Now the character will react to that collider. So I'm gonna make this as a rigid body, and hopefully that will work now. So let me also close those down. Probably I don't need those. So now I'm making a collider, Golaem collider, which is going to be kinematic. And when I'm going to ask my characters to go into it, now you can see that the physics system still runs onto that character, but also the animation as well. And it tries to, follow some rules, but the force which gets applied to the bones is way too big here, so that's why the character stretches a bit. So here, as the force is really too big, you need to find a balance between how much does the physics impact the final posture and how much does the animation impact the final posture. And that's exactly what those servo attributes are about. So you can change here the stiffness and the damping, so you can and the position stiffness and the position damping. So that's one for the orientation and one for the position. And probably if I say that I want to have way more stiffness here, you'll have a different, and especially on position, you have something which is, less flexible here. And if I put a really low value here, let's say 10, probably that's gonna mean that my rigid body won't go too much into this. But here my characters had a too big force, a force which was like maybe too heavy, which put them back into the background here. So really, like, the whole goal when you play with the servo stuff is to figure what's the nice values to put here and to get something which is appropriate. So I'm not sure that sphere is not working, because we can totally see that that cube here is totally acting as a collider. So not really sure. That kind of wrap up that session of today. If you got any questions, now will be the right time to ask for it. Also, I'm gonna go through the chat box and figure if there were some questions before. And I can see that's okay. Let's go back into the previous one. Hey everybody, as for the collisions with the rigid body, you might try to check the advanced option, use kinematic targets. Okay, that's someone from my team which is actually giving me some advice, which is pretty nice, right? Collision with the rigid body, you might try to check the advanced option, use kinematic targets. So that's probably one stuff here within the kinematic behavior advanced, use kinematic targets. I probably will have to check what that option is all about and see if, okay, that's better. So now we can see that the collider is actually reacting to that properly, but the sphere is not following for some reason. But we can see that the collisions is working properly. Okay, that's probably just a refresh from okay, that's just a refresh issue here. But okay, that was it. So whenever the character hits this, now you can see that that shape reacts appropriately, and you got the proper force being applied to it. So thank you, Yan, for the advice. I should probably check what that option is all about. Well, if you want to know more, just check our documentation to see what's going on with that. There's a quick question from Eduardo. Can I make this rigid body interact with enclose? Let me figure. Well, are you speaking about the character rigid body, or are you really speaking about that sphere here? If you're speaking about those character rigid bodies, so those capsules, using them with there's probably a way, because so here what we're having here is a GPU display of the character, so they are not actual geometry of the characters, right? So what you want is to have actual geometry of the characters. So we got something which is called a cache output, where you can use result of the simulation to drive some actual Maya geometry. So we've got a video tutorial about that matter, but you can actually connect real Maya geometry or bones and control their orientation and position based on what's been computed by a cache. Also, we haven't really played with that before. Well, we did play with that, but we also have something called the constraint behavior. So let's say it's really precise what you want to use. Maybe you already know that you want to use the upper part of the characters, which are going to be a couple of capsules. What you can do is use a constraint behavior to constrain real shapes, like Maya shapes, and constrain them to bones. So that would be pretty similar to the cache output, but the difference is the cache output is going to be used when you're in layout mode, rather than the constraint is going to be used when you're in simulation mode. So that's if you wanted to use this onto your characters. If you were speaking about those rigid bodies, those are actual regular meshes, Maya meshes, which are controlled by the physics engine. So if you were having an enclosed in your scene, that would totally interact if you just define this as a kinematic collider within Maya and the physics system of Maya. So there are some ways to play with each other, but they're a bit hacky. And also the question goes with Bifrost, so it's going to be pretty similar answer here. Really, Golaem is within its own context, so it's playing within its own physics engine. So if you want to play with Bifrost or something which is external, you need to have like intermediate format, and intermediate format will be some Maya meshes here that you can just constrain to your characters. Okay, I can see Alexander check for the documentation. So that option I just turned on, if checked, the collision between the ragdoll and dynamic object in the scene will be more accurate, but can be too strong, especially when colliding with a large object. Okay, makes sense. There's a question from Antonio, which is it still convenient to change Maya playback to real-time 60 FPS to handle physics? Well, that's a good question, and let me probably speak about that just quickly. So let's say you do something like an archery simulation, for example, and your arrows, when you throw them, they might go into a really high speed, and let's say they need to collide with characters, and when they collide with characters, you want your characters to react. The thing is, let's say I'm gonna make a really quick arrow just to make my point here. So let's bring a capsules, and I'm gonna quickly change the shape here. So 001, and probably also change the orientation. Going to the x-axis 90 degrees. Oh, where it is? Damn. Okay, so, did I change? Oh, sorry, so that was the translate value I changed. So that's the rotate value. I won't change 90 degrees, and probably my age is going to be a bit smaller. So let's say you're, even smaller, right? 0.5. Let's say this is going to be your arrow. And if you throw it at some regular speed for the arrow, what may happen is like, let's say at frame 10, your arrow is going to be here. And if it goes fast, maybe at frame 11, it may go here. So within Golaem and the physics engine, we're gonna evaluate the position of the arrow when it's here, and what the physics engine will tell, is it in collision? No, it's not. Then the next frame is gonna try to check if it's in collision, and it's not. So here, nothing would happen. We'll still have some, physics sub-steps, and it's not exactly that rule here, which gets applied, but if you want to have really precise collision, or what may happen is frame 10, you're gonna be here, frame 11, you're gonna be there. So it's gonna be in collision, but the results of that collision will be different. You can see the characters is hit into a different position, different orientation, where the right spot will be to detect when it's here, right? When it's like starting to collide with. And you really want to have that reaction when the characters start to collide with. So to achieve that kind of things, ideally, if you can increase the frame rate within Maya, that would be better. You get more proper results by increasing the frame rate. Like within any physics engine, if you were playing with Bifrost or Enclose, it's always better to have a higher frame rate simulation because it deals with physics and you want to have something more proper in terms of collisions and detections. If you wanted also to increase the number of sub-steps, so how many times the physics engine gets updated at every frame. So here it's going to be updated every 3 frame. 3 times per frame. That's something you also want to increase. So that works for 2 Golaem characters. But let's say you are using some Maya mesh to interact with your characters. Those Maya meshes here, they won't be evaluated like 3 times per frame. So this is also why you may want to increase the frame rates on your simulations to sample Maya positions more often and be able to detect collisions more appropriately. So once again, long answer for a short question. If there are more questions, go ahead. That will be the final minutes of that session. In the meantime, let me remind you that tomorrow's session is going to be about interacting characters between rigid bodies. So we'll be playing with just a few. We're having that sphere here and that cube here. But we'll be going into way much details about all those options there. So we're going to play with those, how to interact between characters and actual Maya geometry. So we're going to make one of those spinning bar examples, which have been popular a couple of years ago with a crowd system. So we make a physics bar, spinning bar here, the characters will run, and as soon as they hit by one of those, they just go down and be collided with that spinning bar. Also, next week is going to be about close simulation. So we're going to use the internal close system. We're going to concentrate mostly on the apex close behavior. And the week after is going to be about making your own locomotion. And if that's it, we're going to wrap that session. If some questions come afterwards, feel free to address them to support.golaem.com. Grab the software for free on the website if you haven't done so, and subscribe on the YouTube channel to know about the next sessions. In the meantime, you guys stay safe, take care, and see you tomorrow.